Greetings! Brian here with some information regarding the Atalos project and our approach to identity management. In this video, I will use a well-known example of an identification system and show how cryptography can provide a better way. Consider the case of young Joe Bloggins, who begins working and registers to obtain a social security number so he can pay his income taxes and hopefully collect retirement benefits someday. The agency allocates the next number and prints that along with his name on a paper card that he keeps forever. He uses this number to file his annual tax returns over his working life. Some years later, Bloggins returns to the agency and presents his card. Given all the identity theft and fraud that's happened over the years, how does the agency know for sure that this is really him and not some imposter? How can Bloggins prove that he owns this number? Well, mathematics provides a way to prove ownership of a number. Let's take a look at cryptographic key pairs and see how they can help us. Going back to the registration step, let's imagine that instead of being assigned a number by the Social Security agency, Bloggins generates his own number. Say he begins by flipping a coin 256 times and writing a 0 for heads and a 1 for tails. Or better way, he can use a computer program to do it for him. Either way, this is simply a big random number. Since writing 256 bits is tedious, let's show it in hexadecimal format instead. This is like a self-assigned serial number that Bloggins has created for himself. He keeps it private, stored securely on his phone, and makes a backup copy to put in his safety deposit box. He can use this private key to do math, but he never shows it to anyone and it never leaves his device. If he loses or upgrades his device, he simply restores his keys from backup. Next, Bloggins runs his number through a cryptography algorithm to generate a related number called a public key. The public key is calculated from the private key, but the calculation only goes one way. Nobody can take a public key and find its corresponding private key. Now Bloggins has a pair of numbers, one that he can share with the world and one that he keeps secret. These keys work together. Anything he encrypts using his private key can only be decrypted with his public key. Here is the same public key converted to a scannable computer code. If you scan it with your phone, it will show you this public key string. Going back to the registration scenario, this time Bloggins shows the agency his public key and that's what they record as his social security number. They save this number in their database and maybe even print a card for Bloggins to show his employer. So how does someone prove ownership of a number? Well, cryptography provides a mechanism called digital signatures. Here's how that works. We start with a message and ask our friend to make a digital signature with it. Here's the message as a computer sees it, a sequence of bytes. Our guy first scrambles the message using a standard one-way algorithm called a hashing function. He then encrypts the hash using his private key, and the result is another bunch of bytes called a signature. Note Bloggins used his private key to create the SIG, but the private key is not included in the SIG, nor can it be recovered from the SIG. We can verify a signature by taking the same message and calculating the same scramble. We then pass that scramble and the signature to another cryptographic function. This function produces a yes-no result. It says yes if and only if the signature was generated by the private key corresponding to the given public key. Now elderly Mr. Bloggins returns to the agency to begin receiving benefits. The agency asks him to sign in. They produce a challenge. Bloggins uses his phone to scan and sign the challenge. The agency does the verification and thus has validation of this public key. They look this key up in their database and they find Bloggins' record. Now we have proof positive identification and we didn't even need the physical card, which is good because JJ lost it years ago, no matter. Imagine someone evil has somehow learned Bloggins' public key and printed it on a fake card. Evil goes to the agency and tries to impersonate Bloggins in order to obtain the Social Security payments. Evil has the fake ID, but when given a challenge he can't use the corresponding private key, he doesn't have it, so therefore he can't create the signature that would verify against that key. So he's defeated and he will have to go get an honest job as a daredevil. So now we have a system that prevents identity theft and could eliminate Social Security fraud, which is a very expensive problem. Now, you might wonder what happens if Evil hits Bloggins over the head with a $5 wrench until he turns over his phone and PIN. Well, sadly this is still possible, but at least mathematics has made the cheating more difficult than simply spying on someone or hacking into the agency's database. Thanks for your attention, and we hope to bring you more video explanations in the future.